this week in second grade, we have been working on subtracting multi-digit numbers using the HTO chart and the standard algorithm. We have also introduced the strategy of checking their work using addition. So that's what we're going to do today. So we're first going to set up our total in our HTO chart. This is the bigger number, the total. And as we're saying numbers, we, as much as possible, want to say the units with our numbers, because this is not a 3, this is 3 hundreds, this is not an 8, this is 8 tens, and this is 1 1. So we have 3 hundreds. Oops. 1, 2, 3. We have 8 tens. 1, 2, 3, 4, 5, 6, 7, 8. And we have 1 1. We set our dots up in a 10 frame so that we can quickly see this is 8. Okay. Usually if all 10 are filled, we have 5 on top, 5 on bottom. So now we know that we have 381. That's a way that we teach students to read numbers. We always start in our ones place, whether or not we are adding or subtracting. It doesn't matter. Okay, so we'll ask students 1 minus 7. Well, we only have one dot out over here. We cannot take away 7. So we must come over here to our tens place and unbundle one of those tens. Okay. We're going to draw 10 ones over here. And then we remind students that whatever we do to our drawing, we must also do over here to our equation. So we took a 10 away, so 8 tens minus 1 10 is 7 tens, and we gave those 10 ones to our ones place. So this is no longer a 1, we now have 11. And then our kids know that they are not okay to subtract at this point, because they have to make sure that since they have renamed this 10, that they need to make sure that their numbers match. So they still have 3 hundreds, but now they have 7 tens and they have 11 ones. Now they can subtract. Okay. So 11 minus 7, we want to get rid of 7. 1, 2, 3, 4, 5, 6, 7. And we tell kids to mark out their dots, not erase them, because if they make a mistake, they need to be able to go back and see where they've made their mistake. So we have 4 ones left. We remind them it is not okay simply to copy your 4 from here over here. They will try to do it. We've seen them, even though we've told them 100 times, you cannot just copy your 4 over here, because they won't show any of this invariably. So we advise them put 7 in your head and count up to 11. If they don't know that 11 is minus 7 is 4, they need to put 7 in their head and count up to 11. 7, 8, 9, 10, 11. Is that 4? Yes, it is. Now we can go to our tens place and we can subtract 2. I'm just going to get rid of these 2. 1, 2. And I can very easily see that I have 5 left. Whatever I do to my drawing, I must do to my equation. Okay. 7 minus 2 is 5. If they didn't know that fact already, then they could put 2 in their head and count up 7. 2, 3, 4, 5, 6, 7. It's 5. Now, we have our hundreds place. There's nothing here, so I don't need to subtract anything. I'm just going to bring that 3 down. I'm going to do the same here. We'll teach them that this empty space right here represents a 0. Okay, 0 hundreds. So we have 3 hundreds minus 0 hundreds equals 3. Now at this point, this answer matches this answer, okay? But we're not done, because we want to check it using addition. Now, for the sake of my whiteboard is not very big, I'm going to erase this HTO chart because when we check using addition, we try not, or we encourage them to simply use the standard algorithm just so they can start practicing transitioning over to that. So we remind them that this is our total and there needs to be two parts that make a total. Okay, this is their total. These bottom two numbers are the parts that they're going to add together. And so we have them circle those two parts. Now, they know that when they add, it does not matter which number goes on top, unlike in subtraction. However, I tell them, because of how my brain works, I need to put the 3-digit number on top of the 2-digit number. That's just how my brain works. If it's easy for them to put 27 on top, they are more than welcome to do it that way. Most of them will choose to put the bigger number on top. 354 plus 27. Now at this point, most of them are excited to get away from having to do the drawings, so that's why we start to encourage just using the standard algorithm. Okay, so 4 plus 7, they can put their heads, or not their heads, 7 in their head and count up 4. So 7, 8, 9, 10, 11. Okay, so we have 11 ones. They know that they cannot have 11 ones in the ones place. They have to bundle 10 of those and move that bundle over to their tens place. So when they do that, they are left with 1 1. Now they can add their tens place. 1 10 plus 5 tens is 6 tens. 6 tens plus 2 tens is 8 tens. And again, they have their 300s plus 0 hundreds is 300s. So I'm going to draw an arrow and ask them, does this total down here match this total up here? Okay. There was some confusion before. They were looking at this number and then this 7 and 11, and they would say, no, it doesn't match. So it's really good to see their misconceptions and be able to help them figure out that, no, we're looking at this total needs to match this total that we started out with. If their answers do not match, they have made a mistake somewhere. And we also ran into the problem of some students just trying to make it work by fudging the numbers, which they cannot do. So as you might imagine, in second grade, this takes quite a bit of time to teach and for all the students to be able to understand it. We don't simply want to teach just the standard algorithm. We want to really use those place value drawings so that we can really get them to understand the concept of place value, and that's why we do it. Thank you for following along. I hope that clears some things up for some parents and other grown-ups. Thanks.